Hi Datacampers, welcome! In this course, you will learn how to transform and manipulate images at your will. Let's start. Image processing is a method to perform operations on images in order to enhance them or extract useful information, analyze it, and make decisions. By quantifying the information in images, we can make calculations. Image processing is a subset of computer vision. There is a wide range of applications, such as the analysis of medical images, artificial intelligence, image restoration, surveillance, and many more. The purpose of image processing can be divided into 5 groups. Visualization, to observe objects that are not visible. Image sharpening and restoration, to create a better image. Image retrieval, to seek for the image of interest. Measurement of pattern, to measure objects. And image recognition, to distinguish objects in an image. Scikit-image is an image processing library in Python that is easy to use. Scikit-image makes use of machine learning with built-in functions and can perform complex operations on images with just a few functions. We will use it throughout the course. Let's get started with images. A digital image is an array, or a matrix, of square pixels, picture elements, arranged in columns and rows. In other words, a two-dimensional array, or matrix. These pixels contain information about color and intensity. Here is an example of the matrix of a 2D grayscale image. Here we can see that the first image is a pixelated one. The numbers that we see on top of the following image, next to the first one, correspond to the intensity of each pixel in the image. So at the end, an image can be treated as an intensities matrix. There are some testing purpose images provided by scikit-image in a model called data. If we want to load a colored image of a rocket, we can do so by importing data from scikit-image. And then, from data, call a method named rocket. Two-dimensional color images are often represented in RGB 3 layers of two-dimensional arrays, where the 3 layers represent red, green, and blue channels of the image. Grayscale images only have shades of black and white. Often, the grayscale intensity is stored as an 8-bit integer, giving 255 possible different shades of gray. Grayscale images don't have any color information. So, RGB images have 3 color channels, while grayscale ones have a single channel. We can convert an image with RGB channels into grayscale using the function RGB to gray, provided in the color module. We can also turn grayscale to RGB using gray to RGB. During the course, we will usually use a preloaded function called showImage to display the images using matplotlib. This way, we can focus on image processing code. This is what the showImage function looks like. So if we want to show an image that we have converted to grayscale, we just need to pass the image as the first parameter of the showImage function and the title grayscale as the second parameter. We will then see the image displayed in the console output. Now, let's practice and make